The universe has long captivated us with its immense scales of distance and time. How far out does it stretch? Where does it end? And what lies beyond the star fields and the streams of galaxies that extend as far as telescopes can see? These questions are beginning to yield to a series of extraordinary new lines of investigation and to technologies that are letting us peer not only into the most distant realms of the cosmos, but at the behavior of matter and energy on the smallest of scales. Remarkably, our growing understanding of this kingdom of the ultra-tiny inside the nuclei of atoms is now enabling us to glimpse the answer to the ancient question: how large is the universe? In ancient times, most observers saw the stars as a sphere surrounding the earth, and as the home of deities. The Greeks were the first to see celestial events as phenomena, subject to human investigation, rather than the fickle whims of the gods. One philosopher and sky watcher named Anaxagoras suggested that meteors are made of materials found on Earth, and therefore might have even come from the Earth. Those early astronomers built the foundations of modern science. But they would be shocked to see the discoveries being made by their counterparts today. The stars and planets that once harbored the gods are now seen as infinitesimal parts of a vast scaffolding of matter and energy that extends far out into space. Just how far began to emerge in the 1920s. Working at the huge new 100-inch Hooker telescope on California's Mount Wilson, astronomer Edwin Hubble, along with an assistant named Milt Humason, analyzed the light of fuzzy patches of sky, known then as nebulae. They showed that these were actually distant galaxies located far beyond our own. Hubble and Humason discovered that most of them are moving away from us. The farther out they looked, the faster these objects are receding. This fact, now known as Hubble's law, suggests that there must have been a time when the matter in all these galaxies was together in one place. Everything that astronomers saw in their increasingly large telescopes would have dated back to a singular beginning, now called the Big Bang. That the universe could expand had been predicted back in 1917 by Albert Einstein. Except that Einstein himself didn't believe it until he saw Hubble and Humason's evidence. Einstein's general theory of relativity suggested that galaxies could be moving apart because space itself is expanding. So when a photon gets blasted out from a distant star, it moves through a cosmic landscape that is getting larger and larger, increasing the distance it must travel to reach us. So how large the cosmos has gotten since the Big Bang depends on how long it's been growing, in addition to its expansion rate. Recent precision measurements gathered by the Hubble Space Telescope and other instruments have brought a consensus. that the universe dates back 13.7 billion years. In that time, a beam of light would have traveled 13.7 light years, or about 1.3 quadrillion kilometers. But taking into account the expansion of the universe, the most distant galaxies discovered by the Hubble Space Telescope are actually 46 billion light years away from us in each direction, and almost 92 billion light years from each other. So, is that the size of the universe? It's not, according to a dramatic new theory that describes the origins of the cosmos.
ngusabiki none nshuti yanjye reka ngusabiki ntuzanyibagirwe nshuti ntuzanyibagirwe